It is 4:47 p.m. on a Friday. The newsroom content management system locks for the evening edition in exactly 13 minutes. A junior reporter just filed their draft. The draft contains two specific numeric claims. City unemployment is down 5%, and the mayor's office is sitting on a $12 million surplus. If that surplus is actually a deficit, publishing it guarantees a front-page libel suit. A fluent sentence and a true sentence are entirely different objects, and confusing them under deadline is the fastest way to destroy a publication. Look at the collapse of trust at Sports Illustrated. Publishing AI-generated articles under fake author bylines without a deterministic gatekeeper cost the CEO his job and obliterated the brand's credibility. To prevent this, the engineering requirement is brutal. The architecture must process up to 80 numeric claims from a standard article in under 13 minutes, without hallucinating a single correction. Human editors scale poorly against the volume of AI-assisted content. The only solution is deploying a highly auditable, deterministic machine gatekeeper to intercept claims before they ever reach the public. This chart shows where this specific architecture, the verification and validation agent, sits in a production pipeline. As agent number 11, it acts as the trust hinge, positioned strictly after the data generation of agent 10 and right before the open-ended reasoning of agent 12. The immediate driver forcing the adoption of this architecture is the law. The European Union's Digital Services Act requires very large online platforms to mitigate systemic risks and provide auditable proof of their fact-checking processes. Standard retrieval-augmented generation systems fail completely at this task. Large language models are structurally unsuited for mathematical fact-checking because they are designed to predict the next plausible token of text rather than compute exact absolute values. When you rely entirely on an LLM, the model hallucinates claim values, pulls stale data without realizing it, misses complex claims, and uses tolerances so loose that they mask material errors. To earn a seat in a production newsroom, Agent 11 is built on a single, uncompromising design imperative. You must permanently strip the language model of any truth judgment capabilities. This diagram shows the applied pipeline Agent 11 uses. It begins at the Decompose Claims node. Here, a language model acts solely as a parser, stripping verifiable numeric statements into a structured JSON format containing the metric, value, entity, and time period. Operating strictly as an extraction layer, this primary parser achieves a throughput of roughly 4 claims per second. But at 4:51 p.m., the language model API times out. Without a backup, the pipeline halts, and the newsroom misses its deadline. Immediately, the fallback architecture engages. A deterministic regular expression engine fires, parsing basic numeric digits and unit patterns to bypass the dead API entirely. While this regex fallback loses semantic nuance, struggling with complex phrasing like 5 times higher than the 2% average, it successfully catches about 85% of all numeric claims, keeping the pipeline alive. In high-stakes production pipelines, the extracted claims move to the source retrieval block shown here. The most important architectural choice happens at this stage. There are 0 language models operating in this phase. Instead, the system executes a pure key value lookup. It concatenates the entity, metric, and time period and queries a curated editorial database containing vetted sources like Statistics Canada or municipal financial reports. To bridge the gap between natural text, like Ottawa Q3 surplus, and rigid database keys, the pipeline uses cosine similarity embeddings. The vector math finds the closest semantic match and locks on to the correct data table. A successful lookup returns a highly specific payload, the authoritative true value, the original source URL, the exact timestamp, and the uncertainty margin. If a report is entirely missing from the database, or the timestamp indicates the data is older than 6 months, a strict safety gate triggers. The system refuses to force a match. These unmatched claims drop straight through to a human editor labeled as unverified. Passing the buck proves this agent is a true gatekeeper. This diagram shows the final phase across the cross-check and safety gate nodes, where the retrieved database evidence is mathematically compared to the original text claims. The calculation is handed off to a symbolic solver, like SymPy. By executing exact integer math, the system completely avoids the floating point drift inherent in large language model reasoning. To prevent the system from flagging meaningless rounding differences, engineers implement explicit editorial tolerances. For example, a 0.5 percentage point threshold for rates and a $500,000 limit for monetary values. Testing the claims. The 5% unemployment drop against the actual 4.8 yields a 0.2 delta, sliding safely under the threshold. But the $12 million surplus against the 15.2 million actual yields a 3.2 million delta, violently breaching the $500,000 tolerance barrier. The symbolic check exposes exactly what went wrong. The human reporter accidentally cited a Q3 interim number instead of the year-end total. Mathematical verification catches contextual errors that language models miss entirely. As its final step, the agent takes this deterministically calculated reasoning graph and appends it directly into the article's metadata within the content management system. This forms a rigid JSON audit trail containing the original claim, the authoritative source link, the exact calculated delta, the allowed tolerance limit, and the final machine verdict. This dashboard shows the field impact metrics. With these half-point and $500,000 tolerances strictly enforced, the median end-to-end latency per article is just 45 seconds, easily crushing the 13-minute newsroom deadline. The story clears the desk at 4:56 p.m. The agent intercepted a $3 million discrepancy that would have triggered an immediate retraction and lawsuit. This structured output fulfills the transparency requirements of the European Digital Services Act, proving how the agent arrived at its verdict is a legal necessity. This chart categorizes the organizations deploying this exact architecture across a global fact-checking market projected to reach $1.2 billion by the end of 2026. In the nonprofit sector, UK charity Full Fact deployed an AI-driven harm priority sorter to triage incoming claims, allocating human review resources at internet scale. Commercial operators are heavily invested as well. Companies like Lead Stories and Logically AI use variations of this architecture to predict viral misinformation and fulfill massive business-to-government threat intelligence contracts. Major wire services are integrating these deterministic pipelines to maintain zero-trust editorial defenses, creating an auditable chain of custody in an era dominated by deepfakes. The core philosophy of Agent 11 is absolute discipline. It mechanistically measures, matches, and reports the delta, functioning as the auditable gatekeeper required for the AI era.